If you like our content, please like, subscribe, and click the notification bell to get alerts when we introduce new videos.
So in this module we're going to be taking a look at how you can do some more advanced debugging, fault finding and general data gathering within the IoT controller and the Ruckus IoT suite environment. In this particular module we're going to be looking at how we can connect to the IoT controller's command line interface and then do diagnostics between the controller and each of the access points and devices connected out on the edge. So here we have our IoT controller, and you can see we have one access point that has been configured and onboarded into the environment. So we have our access point, which is currently configured as a Zigbee device, and it's on an IP address of 192.168.111.15, and we can see that, as I said, we have Zigbee radio configured and all the relevant transmit power set up and onboarded accordingly. Additionally, we've configured one IoT device on the IoT controller connected to that access point. So here we can see we have a door sensor that has this particular MAC address ending in 21, which is connected to the gateway, IoT gateway access point via the Zigbee protocol, and we can see we're getting information about the type of device that it is. So it's an IIS zone device, it's a line quality indication of 9.1, and it's RSSI, and it was last seen about 5 minutes ago. And if we open that device, we can get information and an overview of the capabilities of that device. So it's reporting back its zone information, that it's a contact switch, the manufacturer, its battery level, and the current state. Zone status is defined as 4.8. We also have some commands. For example, we can restore it to factory default. So we get an overview of what the device and the access points and the gateways in the system are configured to, and we're getting status information presented to us. So from here I can refresh by clicking on the door name, and I can refresh the information from the IoT controller. So if I now open that sensor and I refresh, you can see the zone status has changed from 4.8 to 4.9. If I close the door again and I refresh, you'll see it drops back to 4.8. So the minimum bit 0, is defining the current contact state of that sensor. So we're able to get that information through the network and into the IoT controller. So what we're going to do now, though, is we're going to take a look at the actual communication between the gateway running on the access point and the IoT controller, and we'll see the messages now passing between. So if for some reason we had a problem where we were not getting state change information being displayed within the controller, we'd be able to now go in and figure out exactly what's going on and gather information about that device and the information being passed between the gateway and the IoT controller. So here we are at our IoT controller now. So you can see we have our main menu, which is giving us all the information about our IoT controller, including my local IP address, the name of the controller, its network, and its N+1 status and configuration. What we can do though now is we can get a lot of information about the connection between the gateways and the IoT controller. So we do that by logging in and using the Command Debugger, so option number 6. So if we open or run at option number 6, the first thing it'll do is it'll ask us which gateway or which IoT enabled access point specifically do we want to look at. So if we had a network of 100 gateways, for example, we're going to get a lot of traffic flowing into this network interface. So we can minimize that and just look at the information coming from one specific gateway which is attached to the sensor that we're interested in. Alternatively, we can just hit return and we can get all information. The other thing we can now do is we can exclude topics. So there are a number of pieces of information coming to us from the gateway about device status, network information, scan status, information about line quality for all of the devices, and we can filter a lot of those out and just focus in on the one specific message that we're interested in by filtering out the others. What we'll do though is we'll actually look at all the messages coming in from the gateway in this particular case. So we hit return. So now what will happen is the gateway and the debugger will now connect into the IoT controller's broker and actually now look for all topics and messages coming from the gateway and from the controller. So here you can see we've had a notification from the gateway of an event. So you can see that the gateway device EUID has been updated, so it's told us that the MAC address of the EUID of the device, so this is the MAC address of the access point. the event ID of 3, and then the data. So we can see that the access point is reporting as online, and that it is currently operating correctly. It has a radio connected onto the USB interface, how much memory is being used, how much CPU is being used, and the kind of network stack information. And the access point is going to push this information out to the IoT controller on a very regular basis. So you'll see every 10 or 15 seconds, you'll see a push notification from each access point to the controller, just giving a general update on the health and status of the network and of the system. So what we'll do is, you can see there's some additional commands that have now come in. So we've got some settings commands. So it's now updating us with all the settings information, scan list information. So it's telling us what's going on, how many devices it's seen, what's going on acknowledgement wise, and improvement. And again, the event information is coming in regularly. So what I can do though is I can stop this by doing a Control C. And what we'll do is we'll rerun it now, and we'll drop those event notifications. So what we can do is we'll rerun our debugger. We'll again look for all, but this time we will filter out all of the events notifications that are coming from the gateway to minimize the amount of traffic. So again, we connect to the controller connects to the broker, and now we can now see the data. So now you won't be getting those updates from the IoT controllers from the access point for the events notification. So we'll only now be getting the other information. So what I can do though to actually now see what's going on at a Zigbee level, and with regards to traffic between the access point and the Zigbee radio and a device on the endpoint, is I can trigger an event on our door sensor that is attached to this gateway. So if I open the door contact sensor now, you'll see you immediately get a notification from the IoT gateway that a Zigbee event has happened and a device has sent an attribute change. So you can see that the gateway ID is listed here, and you can also see that the endpoint ID of the Zigbee device is listed here, which is the same as we saw on our dashboard. We can also see that what has changed is endpoint ID 1 and cluster ID 0x500, which is an IAS zone cluster. And we can see also that the attributes have changed. So we can see attribute ID 2 has changed, and the acknowledgement was okay, and the value has now changed to state 3.1. Okay, so this is the key thing now that you can see, is that the value has indicated, bit number 1 has indicated that the door has been opened. And if I close the door now, you'll see we get another immediate notification from the gateway telling us that the same device as before, same cluster and endpoint, has now changed to a value of 3.0. So immediately we're able to check and validate that the sensor is correctly communicating with the access point, and the access point is correctly pushing that information to the IoT controller. So we have a perfectly good and connected end-to-end pipe from the sensor all the way into the controller. And using the debugger now, we're able to monitor that information, and we're able to see all the state changes coming from that device into the controller. So again, this particular device also supports a tamper alarm. So if I trigger the tamper alarm on this device now, you can see that we get another state change notification, and again the same device, but now we've changed the second bit. So we've changed from 3.0 to 3.4, indicating that the tamper alarm has been triggered on this particular device. And we can exit that by doing a Control C within our command line interface. So that completes a very simple rudimentary overview of how to use the command line debugger within the Ruckus IoT suite and the Ruckus IoT controller to check for end-to-end connection between the Zigbee device and the IoT controller.